When I'm saying about the dual batch, so two kind of employment, putting two legs into different world. One is in academia and one in industry. So it's actually fun because in academia we try to create new knowledge, while in industry we try to solve problems by applying those knowledge. And sometimes we really find a lot of problems that even we don't have knowledge to solve that. So then we again come back to academia and then see the new courses. For example, now we at in VACHO we try to add a lot of content of big data in different courses. For instance, we try to add some of the open source tools in our different study curriculum to just to give the student a faster warm-up experience, because open source tools in general a bit complicated when it comes to configuring all those kind of things and integrating with different tools. So it's like some new kind of technological demand in these days when it comes to big data, as well as in general, if you do coding or whatever, software engineering, you need to know like a lot of new skills in these days, not like just C or Java, then it's life is become very easy and you just go straight. So that's how, like, if something where we have this kind of position where we can have direct access in the industry that what's actually demanding, as well as access to the academia that what a student needs to know more. It's actually quite exciting, but also challenging to balance these two. Anyway, so today's in this presentation or in this think tank, I will not presenting any of my employers. So it's like feel free to put any questions so that we could have very common discussions as well as a common understanding, and we could discuss anything because it's just like our opinions. Great. So are any of you already doing some big data project? Just to get a view about the audience. Okay, great. So there are some. Because what I thought that we could talk a lot about very like trends and general things, not to being very specific on some problems, just to get from this talk. Maybe we know big data or data-driven development is kind of things that is very promising, but also we could know a bit more than why people are talking so much about the data. So like something like this sort of settings. So one of the slide here, just to giving you some summary of what actually we could expect from today. That we will talk a lot about data, and then of course this data comes from somewhere. It could be some platform or some infrastructure, or it could be like we as a data-driven product user create this data, or it's something else. But there is something somewhere that data is actually produced. Then why this data is so interesting? Because it could generate some new knowledge, like something that's we haven't observed before, and then it becoming maybe very business critical, or it could be like giving us a lot of new knowledge for societal development. So why not try to understand this data? So that's one thing. Then of course, for the big companies, it's actually a matter of revenue, how they could earn more money. For like researchers, it could be like something that accelerate innovation, so they could come up with new services, come up with some ideas of new product. So all these things actually connected, right? To get data, you need to have like a lot of services, and then to improve these services, you need to generate some knowledge by applying some analytics on top of it, and then it might get some new knowledge. It improves the service or it gets new money. So all these kind of things we will try to understand today. Any questions so far? I'm talking so fast or so slow? I mean, we could take it informal, so just feel free to interrupt me in any case. Yeah?
It's good you're slow. It's good you are slow.
Okay.
Yes.
CDR or data, what's that?
It's called a detailed record. It's called a call, so it's like a telecom operator data. So it's actually the data that's a billing data. So when you get the phone bills, so whom you call, so this like a detail of records. Then location data you already know. So streaming services like the data, for instance, Spotify store. So they have like very big data projects as well, and they are. So this kind of data is actually coming from. So here's the telco services. You have streaming services, smart home. It's like this Internet of Things. So all the things actually you could use from smart city, so like smart traffic monitoring, classified services, for example, Blocket. So those services are called classified services, Fin, so where you could buy and sell some products. So what then I'm trying to say that there is some kind of digital service ecosystems, right? And this ecosystem actually comes from some kind of enabling devices. So all kind of smart devices that actually we are using in these days, we could consider as like enabler. We have then Facebook, LinkedIn, so all kind of human interaction providers who actually taking care of the graph, your social graph. So that's actually promoter. These tools are these devices are the enablers, and then you have this graph which actually creates a lot of interactions. Those interactions actually never happened before if you don't have these services. Then of course, to interact with, you need different types of content. So you see like video, audio, all those kind of content. And then there is like some kind of distribution hubs, like the platform where this. So if you consider internet as a global distribution hub, it's for sure. But on top of internet, there are every players like telecom providers, internet service providers, then more like if you consider it like a Facebook itself is a platform. When you consider like a Facebook platform API to develop some kind of apps, like gaming apps, they use Facebook platform API quite heavily to distribute their content. So this like the ecosystem that's actually very important for big data, right? Because if one of these is not working, then actually we, we will not get that much data that we actually getting today. So if we just look a bit more about each of these enablers, why we're talking about it, because it actually provides a lot of new information. So smart object, social graph, digital content, distribution hub. So in a way, if we consider like this whole digital service ecosystems, it contributes to big data. And when I'm saying these things, it sounds a bit very strong comment. So why? Because like if we look back in my line of research, like what I did even before when I do research in big data area, I started something with social media analytics. I worked that time with some research. We publish some patent applications, so one on social data ranking. So that time we actually work with a lot with social data, but more on social recommendations, social data management perspective. And that's actually come up like a patent. Then we work on pervasive communications, so it's like more on the platform side, so social media, how the data we actually distribute in a more controlled viral way. So if you have something and you would like to distribute it within the world without spamming people, what kind of approach you should follow. So this sort of background actually, then I also work a bit very fast days, like 2009, 2010. This app is developed now. It's like very highly interactive apps are coming, but this whole thing actually helps me to understand that actually to get this like why big data is actually booming, because this whole ecosystem, everything actually are now contributing in data production. So we can now start with big data. Yeah. So how we define actually big data? People are talking a lot about big data. Companies are talking is in Facebook or in LinkedIn. We get a lot of job offers to be data scientist. So why it's like so much talk about it? Or what's how people define big data? So one of the very funny definitions. So let's say that you work with data and now data becomes unmanageable. That means that you are actually working with big data. Because if you say that, okay, to declare a project as like a big data project, you need to have like petabytes of data or terabytes of data or exabyte of data. It might not be true, because every company have their own requirement and they define their problem in their own way. So there is no common way of saying that, okay, I work with big data and you are not working with big data. So it's actually matter that how they take their problem and how they try to find or address that problem to get a solution. So what common element are there? These 3V: volume, velocity, variety. I guess most of us know these 3V that construct some big data idea. So when you talk about volume, it's actually we're talking about the size of the data set. So how big data we're talking about. When you talk about velocity, so data actually we could deal with in many different ways. So one way is to look at historic data. So data is stored in somewhere, and then we start some analysis. So that's like one kind of data. And then data which is collected from a stream, right? So it's like something is happening now, and we try to get all these stream events and then put some analytics on top of it and try to get back to that customer, that users, to give them. So that's like something with real-time data or streaming data. Then variety, yes. So in before, most of the data analysts use SQL, so they are very good in that, and then they use some proprietary tools like SAS or some Oracle-based solutions, and then they do analysis and then give some decision makers some kind of analytic results. So that's their way of doing. So all the data they actually used to do in a classical approach is actually structured data. But then when big data problems is evolved, then they start to thinking about all kind of data, so unstructured, which means that you don't know, you don't have these variables, assigned variables. You don't know what are the columns or what are the rows, or you have to define it in your way. So it's completely messy. There is no structure, but maybe you could give this kind of data some kind of structure. So that's then, this variety is come in pictures, and people started to look at the data that they usually don't look at. So this 3V in big data, people always talk about, and we are looking in that now. So is there any conceptual questions regarding that? What or why we should think about big data, or anything that you would like to ask? Yeah, please.
Maybe you can comment on which of these have, you have maybe has most impact on the accuracy of the data,
Mm-hmm.
because it's a variable that isn't, you know, and it's
Mm-hmm. Yeah.
I was thinking about the
Mm-hmm.
funny definition of when the data becomes a problem.
Yeah. Yeah.
And
Yes. I mean, you're talking about accuracy, so reliability of the data.
exactly.
Yeah. Yes. So that's obviously one of the important question, and that's actually also somehow hidden here. So when you have some kind of unstructured data, and you want to structure it, so you started to look in that and try to find something that's actually very valuable. Then it's actually used to collect those sort of data. When you see that it's not that reliable, it doesn't make any sense, then you stop storing those sort of data. So, that's actually very important as well, because how much resource you would like to put depends on how much data you would like to store, as well as how long. So it's not like you you store the data, you get some analytic report, and then you destroy this data. It's not like that, right? That is straight. So it's really important, and every data point actually matter of cost. It doesn't matter how small it is, but it cost. So there was a survey that's driven by IBM with the University of Oxford. So they are trying to understand how, like, industry look at data or big data. So they were asked, so what's you think about big data or data? So they come up like, so it's real-time information. So it's non-traditional source of information. So they give like many different, so it's like a latest buzzword. So all those kind of response comes out. But one thing comes out, which is many people says like real-time information. So for them, like real-time information is something very important when they talk about big data. And I also would like to mention that when it comes to big data, actually Sweden is very a strong player. I have some other slides that's to defend that statement. But here is like one of the project Scania have to track where their vehicles goes, and try to predict their vehicles' health, to know that if they need to do something, some kind of repairing of some of the machines inside their vehicles. So this is like something that they usually don't do before, but now when they have like this sort of all sort of data, so they try to keep looking the health informations of their vehicles. So isn't it cool? So it's like one of the use case like big companies are having. So they have the platform, they have the solutions. So they are trying to making new kind of use cases, that how they actually attract. Then another area of use of big data, if you see, uh, just to do societal development. For example, here is a project that's actually run by Telenor Research together with, I guess, Harvard School of Health. So what they try to do in this project is that risk discovering risk map. So what's this risk about? Is about this fever called dengue. So they try to collect like nationwide all telecom data, so CDR data for like 7 months, and try to make this mobility pattern, that how people move around the country, and then they correlate this information so with the dengue epidemics. So how this actually disease is spreading to the country. So if they can predict that what is the next most significant place where this disease can spread, they could do some preventive measure. So it's like quite important for that country, because it's like killing thousands of people every year, so helps them quite a lot.
How would that be correlated to dengue? I mean, have people told them I have this mobile phone and I am having dengue?
No. So it's actually dengue is actually spreaded through this mosquito, right?
Yeah.
With the bite. But the research found shows that this in a whole lifetime, a mosquito only can go 100 meter. So that's like their maximum distance since their birth to death. Now, then how this actually is spreading? It's actually human who actually carrying this disease from one place to another place. And then what they do is that they try to find how people are actually moving around the country. So let's say that you live in one place. So how many people every day actually moving from that particular village to rest of the countries? And is this information correlates or not? So they have like this 7 months of data. So they do all this historical data analysis, and then they correlate these informations. Based on this historical evidence, then they started to predicting that, okay, these are the, so they actually try to figure out some kind of risk map of the whole country and spotting those places that could be like the next possible places where this disease can happen.
I was associating to Apple as a health program where people say that I have diabetes and I want to be in this particular research.
Yeah. I mean, so it's becoming very interesting when you have like this smart device, and you would like to help people, especially the people who do with health data, to contribute your data to make like a lot of interesting research on top of it. So what Apple is doing is providing something called a health kit. So actually you can turn on different kind of sensors in your mobile device, and this data is actually would be anonymized and then shared with this institute that actually working with this data. So that's quite progressing, and many other following the same pattern. They're also thinking that how people can contribute in this research with data. Yeah. So when we are talking about big data, it's many people then come up with data science. So what's the data and what is then data science? So data science is important, right? To work with big data, because it gives you the knowledge or the competence you actually need to work with data. So when I started to work at Telenor Research, uh, and my business title was data scientist. But yeah, what kind of competence at that time I had? It is actually, I was just a computer scientist, just a fresh graduate, had my PhD. So this whole thing, it's actually building, in my view. So it's not like to be a data scientist, you have to have like all statistical knowledge. You need to have a lot of knowledge of data mining or machine learning, because all these things, again, related with the project that you're trying to solve. And there are a lot of relevant elements that's even not covered here. Let's say that you have all this knowledge, you know data mining, you know statistics, you know or predictive analytics. But the fundamental things is actually this platform, analytical platform, or the tools. You don't use those tools, or you don't know how to integrate data, how to clean data, then you again lost. So data science actually allow us to in a way to work with data, to gives us some basic concepts that might be interesting, but not very strict as the followers. And then you will develop your own set of skills that will make you special in a sense. Some people just know a lot about Hadoop, this big data platform, and they're just selling that competence in big data world. Then some people just very good in machine learning, and they're just selling that. And all of them are calling some kind of data scientist. So that's my view of data science. Nothing to, and nowadays there are many set of data scientists. So some with PhD, some with basic degree like bachelor, some with masters. All are data scientists, and actually they are doing cool whatever their academic knowledge is, because it's more like what kind of projects you are working on. So if you have a very exciting project, then you could learn a lot, even though you don't have PhD or if you don't have masters. It's not like that. Maybe the PhDs who work in a project is not that exciting or that interesting. So it's actually completely interdisciplinary, and competence is actually varying quite high. Different people coming from many different backgrounds. Economists are also getting a lot of attraction or something from this perspective. They are being also highly valued. And when you talk about data science, so where you would like to apply this science, so all kind of data product, right? So Google is masters in that. Search engine, speech recognition, spell. So whatever the product Google developed, it's actually data product. And not only Google, so you have Facebook, you have Amazon, classified services. So all these kind of services are. So here is actually very simple way of understanding big data projects. Let's say that you have a small data. Don't think about big data. Just you have a data set. So and you would like to do something. So what actually we do in general. So we've always like when you think about doing something with big data or data. So what kind of mathematical or algorithmic or logical model we need to develop. So this is like the intelligence part, and that's actually you need to tune your data, and then you get something, and it could be actionable insight, and it could be very valuable. These informations, let's say that for taking some important decisions. So this is actually these are the three things. If you would like to boil down or simplified or oversimplified data science. So you have a data set, you put this data in some model, and then you get some insight. And that's actually all the big data projects, or most of the big data project is actually trying to do. Now here you could put a lot of complexity, so you scale up your data from terabytes to petabytes, or maybe more larger than that. Here you come up with much complicated method for which you need huge amount of computation power. And then the actionable insight, actually you are trying to get, maybe you want to predict so complicated things that actually traditional models in general fail to have. So you could actually complicate this model a lot, but in general, you could start with very simple approach. One of the project that I worked at a very early time at right after joining at Telenor Research is called device analyzer, we called it. So it's actually handset data to analyze how people use their handset, what kind of apps, for instance, people are using to find some applications. Let's say that what's at the top 10 applications at this time is going around in different kind of segments. And then how you would like to correlate this information, let's say that, to finding next best applications. So that was something that we work with one of the university, I guess, in UK. It's Oxford, I guess. No, Cambridge, yeah. With Cambridge University. So in Norway we do some study. We get like 674 users who use this device analyzer app, which anonymously actually upload all kind of data that user can potentially produce. But of course it's anonymized. We develop some kind of analytical framework. So let's say these are the users who are using this device analyzer app and uploading data. There is like some kind of cloud infrastructure to pushing this data. And this is like a very good example of messy data. So if you look at how the actual data looks like of device analyzer, it's really, really messy, not structured at all. Then we push this data in a Hadoop file system, HDFS, because it's large. We're now talking about like terabytes of data. So then we try to understand this data and try to give this some kind of structure. So we take with a bigger sample, try to clean this data. When we have like a more structured data set, we import this data in some kind of more expensive but easy to manage relational DB. So we put it in Oracle system, and then we run some SQL script and other script to make some actionable insights. Apart from that, here we also use Python, some R, and then for visualization we use QGIS. For making some animations we use processing. So you see, like it's a lot of dependency that I was talking about when I was describing a bit data science. That a lot of things, but we don't need to care about a lot of things from the very beginning. It all depends on what kind of problem we have and how we address this problem. So for this problem, we developed this.
Did you say what problem it was?
Yeah, so the problem was to understand what actually, let's say that apps uses.
How you use apps?
What kind of apps users are using and how you could rank these apps. This could be like one problem. So traditionally we know that, okay, how the users is actually using telecom services. So let's say that who is happy users in terms of making a lot of call, who is not that happy users, because we see how much bill they have, right? But when it comes to OTT, on the top internet services, then it's actually really, we don't know anything, right? It's actually all the internet players knows that, okay, how you are using Google services. Then Google knows everything that, okay, how you are using Gmails or whatever you are using. Just to get a bit understanding that what kind of apps might be interesting or how the people are using this kind of apps, you could do some passive way, right? And that could be like to get this kind of app in the users, of course, with the users' consent. We're not talking about to doing something without a user's consent. And then user could share this data in an anonymous way, and it started to to make sense out of this data. And of course, you could do it in an aggregated level, not like pinpointing an individual user. So all the analysis you can do from a whole community, not for an individual basis. So there are many different way you address the problem. And in this case, for example, we try to see how the people are using and which apps actually the people are used most. So we try to also aggregate. So you see like Facebook is like very heavy browsing. People are browse a lot. Then we found like Candy Crush at that time. People are using a lot, but with not all the users. So you see like this is like kind of addictive app that those are the users who use it heavily. Those who don't use it, they don't use it. So that's some knowledge or some insights we know. Then what else we can learn from this? We can learn that where users actually fire up Spotify. So which are the places people actually like to listen music, streaming music, and where, when, all those kind of things. Then now you could even compare two streaming apps. So one is like Spotify, another is Wimp. So this sort of thing, I mean, people usually don't think we need to do this, right? But when you have data and you could visualize this information, then you can feel like, oh yeah, it's a interesting insights. So now you know that, oh, in this southern part of Norway, Spotify is so popular, and not only Spotify, a lot of people also use Wimp. On the other hand, other part, rest of the country, a lot of Spotify users, but not that much. So, like nationwide, Spotify is popular, but region-wise, there is like in Oslo, where a lot of people use Wimp. So, and now you could make this. Okay, maybe you want so let's say that I'm just articulating here. So you want to make your customers happy. So you say that, okay, for my customers, we would like to make Spotify traffic free. So whatever you stream with Spotify as a certain operator customer, you don't need to pay anything, because you already knows that there are a lot of people all over the country who are using Spotify. So you get this first insight, and then you add this in your bundle offer, and then you get a lot of new customers. So that's like how you get some business benefits. On the other hand, you could also help these companies to improve their services by providing this knowledge, and many more things you can do. But what I'm trying to show here is like this powerfulness of the data. So when you have data, then you could actually get started to do a lot of things. That's gives you a lot of new knowledge. And when I talk about new knowledge, here is, yeah, maybe this is,
One of the things we can do is take coffee.
yeah, maybe after this slide.
Yes.
What about,
With
yeah,
this slide.
yeah. So this like some new knowledge, right? Why I'm saying some new knowledge? So here we try to understand that, okay, so if a user's what's the apps network? So if someone use Happy on Facebook, so what are the other apps Facebook actually taking up, like lifting on top? So you said can we correlate, like if you users use it a lot Facebook, it doesn't mean that you also use let's say Instagram, or if you use a lot Google Chrome, it doesn't mean that you also use Candy Crush. So can we try to get something like a network of apps that gives us this kind of knowledge? So it's just an illustration. It doesn't make that much sense, but the idea was something similar. So when we see like this kind of project and makes sense, so why not somewhere else? So we run like this same project in Bangladesh with a bigger segment. So we there. So in Bangladesh we recruited almost 2,498. The segment is like male 2,238, female smaller segment of course 260. So there's like a different segment of age. And why we did that? We just like to apply like same method, same approach, just to get to the view that what people may like. Is it like very different from Europe in Asia? Or the users have like same kind of requirement when it comes to apps users, or is it completely different? Because Telenor is a global company. It has like more than 200 million of customers all over the world. So it's not like in Scandinavia, the customers we have, it's important for us. It's like all the customers. So that's something we always do when we get some insight from one project. We try to replicate the whole project in rest of our business units sometimes. And when it comes to discussions, privacy is actually very important. And one of you already asked one of the questions regarding privacy. So how we anonymize the data, and it's always important, I will say. So how Facebook guide us to be more privacy concerned. So you like to share something, okay? The best way, well, look at your audience with whom you are sharing your information. So you would like to share something, look at your audience. But it's not enough, right? If you upload something and if you see like, well, your information is misused by the service provider, then you will definitely angry. So it's not, I mean, we can't say our users or whatever that, okay, take care all the responsibility on your side and we just provide the services and that's it. So there are also try to help a lot to users to learn about privacy. So Facebook always promote a lot of informations to their users to learn a bit more on that. But in general, these companies, like these data-driven companies, are have to live with that. Privacy is very important because somebody somehow wants this data. This data is very, very useful for recommendations. So when you would like to buy something, what you would like to buy, the choice is tremendous. If you think about online e-commerce sites, even in Sweden, a lot of possibilities. And within these sites, there are thousands of products. So which product you would like to buy, it depends on how the service providers make your profile, what kind of information, the things that you might be interested in. And that helps you as well as your service provider. Because if you get a product that you really like to buy and you get it without looking around that much, it saves your time. So definitely you're going to be happy. On the other hand, if you buy that product, the company is happy, right? Either it's getting money from as an ad provider, or it's getting money by directly selling that product. So all these things are really interesting, but as someone owns this data, it could be the service provider, it could be the consumer, it could be governmental body. So privacy, trust, these are very important. And we also want to know more about the privacy of the users. What users actually is self-thinking. So what we did, we run, I mean, when it comes to Europe, users are more like a bit more educated, so they understand that privacy is important. So there is no question about it. So people are very respectful. So what about the users' mental settings in Asia? So we try to understand that, and then we say that, okay, run as a survey asking users, okay, do you know that what Facebook do with your data, how they use your data, or how Google use your data, and what how they use this data. So we put this whole discussions with some questionnaire and says that, okay, as you know now that Facebook or Google use your data or read your emails just because they want to push some ads in your interface, web interface, would you like to stop using Facebook, or would you like to stop using Google? They say no. Most of the users says no. They would like to continue use whatever they are going to, until unless they are happy with the service they're getting free from these providers, they are happy, or how they manage their data. So in a way, what we're thinking that even we are privacy concerned, but when it comes to the value of a service or a product, it's actually sometimes it could go beyond of our limit, right? We could just say that, oh, I don't care that much how Google is using my data, since Google's Gmail or Google's Drive is very, very interesting to me, and I would keep using these services. So this way, the privacy, the way we think today, it could maybe change in next 10 years much than what we are thinking today. Technology helps us to do a lot of things in a simple way. On the other hand, there are certain misuse of it. So we need to teach our kids, people in the society, how to use this technology to get benefit of it rather than to be victim of it. So of course there is a different. There is a campaign in Norway, Telenor used to do. It's called Bruku. It's a Norwegian kind of slang. It means that use your head. So what we do in this day, we try to talk with the kids on the street to talk about this internet bullying. So there's many corrupt people who like to put lots of interesting informations on the internet, saying they're youngster, but maybe they're 60 years old, and then so we try to educate people on the street with these informations that okay, this sort of things can happen, so always use your head. So here is some hypotheses we had when we run this privacy study. So here a bit more on
Could you go back one?
yeah. Yeah. So in this think tank, we start with some of ecosystem we call the digital services ecosystem. That's we take as a standpoint of data product or data service providers. Then we talk about big data. Then we get to know about it a bit. And then we started to look at one of the project and some of the result, how we analyze it, what kind of framework we used. So that was the basic, and then we started now entering a bit one specific area of data analytics. So if we consider 3V, in the 3V we learn one thing is variety, and then we had this velocity. So it's about velocity. So when we have work in device analyzer project, we worked on historical data. That was not stream data. But here when you talk about real-time analytics, that means that we are working on some streaming data. And that's why it's interesting or a bit challenging, because of three different facts. So in real-time analytics project, whatever the project is, you might want to achieve all or one of these. So you want your first maybe uh, the the objective is to get all this data really fast. So real-time collection of data. So you get all of your data really fast. And then the second thing you really like to do to process this data really fast. So that's like some kind of online learning method to do some. Maybe is it like this or no? Yes. And then the third thing is to response. So how fast are you response to the service to the customers? So this is like and this all things is like time is the main element. So that's these models are called like online learning model. So you have like classical methods, for instance, for clustering. The basic method is k-means, for example, and then you make a streaming k-means, which is continuously updating the model as well as creating new clusters. Apart from the clusters, it's
Continuously update.
yeah, yeah. So that's the challenging part. And this is very interesting because there are a lot of source of streaming data and people want to use it. Let's say if we see here the sources. So if you have a big infrastructure and you want to see how its operations going on, so you want to do some kind of operational monitoring. And for that, of course, you want to consider streaming data for web analytics, online advertising, social media. So there's like lots of source that contributes in it. And when it comes to Scandic perspective, it's actually really exciting. For instance, King, they are also like to do a lot on streaming data. Spotify, they are doing a lot. Klarna is doing a lot. When you see different kind of funding agencies like Swedish funding agencies, they're putting huge amount of money on big data project. So BTS have a big data project for next 10 years or something, 5 years. Recently, Six is getting a lot of money to do a lot of research on it. So they do stream analytics. So this is like just like in a way beginning because from Linnaeus University's perspective, our department is quite open for industrial collaboration. Especially Marcello Milrad, head of the department, he is very in this process. What's interesting in the foundations you mentioned, KK, it's that if you like to, for instance, work in a project where you get, I will say it in a different way, you can get a free resource in your project from university, because this resource actually hired from the money university will get from KK Foundation, but will work in your project. But KK would like to finance only the project that gets this industrial endorsement, that okay, this project is interesting and it's running inside the industry, so let's work on this project. So that's the settings that KK like to have.
And they
So
always have this triangle drama.
yeah. So now there is a call going around by which university can always hire senior researcher for industry if a industry like to run a interesting project. It don't need to be on big data. It could be anything that's have research value as well as a potential industrial value. Så that's
Vi kan också projekt 15. Ni kan se på Google Figures weapons. Det är bara att kontakta mig eller Juwel.
Yeah, I mean, this area is really, really interesting. If you see 59 patents hit in 2014, so industry is very active in real-time analytics. So just to give you uh, some idea on the framework, so you have like data product, you get the stream data, collect it with a messaging platform. Here we are talking about Kafka. You push this data in another tools. It's called Spark. So all the tools here, or mostly, are open source. So anyone can download it without paying anything. And then, like you say, so this provides some of the functionalities for making your model online. So, and they have quite a rich library. So most of the machine learning algorithms are already implemented there. So you just need to feed your data and push it there. You could also do a lot of re-engineering with R, Python, these sort of things, and then it start produce some insights. So that's in real-time analytics project we're trying to do. It's not like only Spark. There are lots of even within open source communities. There are Flink, there are other Samja, all are very good for open source. Yeah, so we're pretty near to end. We mentioned some framework, we mentioned some area of real-time analytics. We also learning a bit on big data. But what are the application areas? I mean, why we need to do this? So there are lots of interesting areas here, just a few examples. So digital distribution.
To what extent do you use open source tools or commercial tools or?
I guess the trend, yes, I guess the trend is now on open source, using open source tools. Even the companies, like if you think about Cloudera or Hortonworks, these are the companies like selling some of the big data solutions. They are even using open source tools and rebranding it with some management interface. So
In your own research, do you use open source tools?
yes, in research we use and we try to understand it more and more, because open source gives you lots of freedom, right? You do a lot of re-engineering. On the other hand, proprietary ones, it's not only the tools you need to learn or something, but it's also sometimes they want not you to be engaged in the tools. Why? Because they also want to self-support. They want to do a lot of so open source in that sense is very good, and in research we try to explore more and more on that. We also think this like real-time analytics could be very good for mobile financial services to do, for instance, real-time credit scoring. Sometimes I say like online classified. So here you can see an example, Bitroy.com. It's actually a Swedish company, and now they are in Bangladesh. So it's like a very interesting example, because this kind of services not only interesting maybe from here. Then this is the another services in Bangladesh, but the owner is Schibsted, Norwegian company. So that's and the real-time information is very interesting, right? Because when you are looking some kind of product, based on how you click on different product, if you get some real-time recommendations, what could be very interesting for you, you might buy it. So then we also recently we submitted a project for Vinnova funding. it's a collaboration project with India, and what we are trying to do in this project is to develop intelligent marketing tools. Here is just a very basic example, right? That how we can buy product here in Sweden using digital kind of things, and how people buy product maybe in India in some rural areas. So the difference, if you see, is quite high, right? So Swedish funding agency Vinnova have like launched some cooperation project ideas where you could use different kind of innovative ideas which based in Sweden, and then you could see how it could potentially solve different kind of business needs back in India, and both countries could be beneficial in a sense that the business model you will develop help both. So that's the last slide, I guess.